Hello, hello, hello. Good morning, everyone. Mega love shout out to all the subscribers and followers of this channel. And if you're new to my channel, please one subscribe, share. Don't forget to ring the bell buttons for the next notification. 3, like, leave a comment, subscribe. 4, subscribe. All right. Our lesson for today is how to solve linear inequalities into variables. And this is your teacher, Marife Adonis. Okay, so we have solving linear inequalities in two variables. So our concept, represent and solve systems of inequalities graphically. Okay, our EQ, how do I represent the solution of inequality into variables? So some of the common vocabulary that you are going to encounter here is a solutions region, boundaries. No, so for boundaries we have solid and non-solid. We have inclusive, non-inclusive, half plane, and T-plane. Okay, next. Solving a linear inequality into variables is like graphing a linear equation with a few extra steps that will be explained on the following slides. Remember that inequality have definitely many solutions, and all the solutions get represented using shading. Okay, so we have linear inequalities into variables has half plane as a set of solutions like this, and a half plane is a region containing all points that have one boundary, and this one, no? Okay, and which is straight line that continues in both directions and infinitely. Okay, so we have inequality brothers. So we have here the I is a symbol of greater than. The other I, the left I represent less than. Of course, the nose, and this is open. No, so since it's not closed, it means it's non-inclusive or also known as open. Okay, while here we have the greater than or equal to, less than or equal to, and this one is inclusive or also known as close. Now here are the steps to graphing a linear inequality in two variables. So number one, graph the inequality as a linear equation. Yeah, whatever we do in the linear equation with two variables, the same here. If the inequality is inclusive, or that is less than or equal to or greater than is equal to, use a solid line. Okay? If the inequality is non-inclusive, that's less than, or use a dashed line. Okay, so when we say solid line, of course, we have the solid like this. Okay, so we have the solid line, and if we have the dashed line, it's like this. Okay, it's not continuous. And then for step after na step 2, we have shade the half plane above the y-intercept for greater than or greater than equals to. If our graph is that's up, okay, that means greater than. If the shade half plane below y-intercept, it's less than or less than to equal to. Then check your answer by picking test point and substituting into the inequality. So whatever we do in checking the inequality or the equation is the same thing here with inequalities. Okay, so yeah. Next. Okay, so we have here practice number 1. So graph the solutions to the following inequality if y is greater than x plus 3. Okay, so first graph the inequality as linear equation. Since the inequality is non-inclusive, use a dashed line. Okay, so to graph the line, plot the y-intercept first, that's 0, 3, then use the slope to find the second point. Then the slope is 1, so count 1 unit to the right and 1 unit to the plot and the second point. So connect the 2 points and extend the line to the edges of the coordinate plane. Okay, so we have here the graph. Okay, so number 2, shade the appropriate area. So since the symbol is greater than, it's used OAO shade above the y-intercept. So this one, no? And shade, so we have y is equal x plus 3. So that's it. No, that means y is greater than x plus 3. Okay, so step 3, pick a test point above or below the line and substitute the point to the inequality. So we choose 0 as x and 0 as y because this point is easy to substitute into the inequality. So therefore, 0 is greater than x plus 3. The final answer is x or 0 is greater than 3. So this is false. Since the test point makes the inequality false, all points on the side of the line make inequality false. So therefore, we cannot correct shade above the line. Okay, so we have here guided practice example 2. Graph the solution to the following inequality, that is y is greater than or equal to 3x plus 2. So first, graph the inequality as linear equation. Since inequality is inclusive, use the solid line. So it would becomes y is equal to 3x plus 2. So to graph the line, plot the y-intercept first, that's 0, 2. Then use the slope to find the second point. The slope is 3. Now, so count 3 units to the right and 1 unit to the plot the second point. So connect the 2 points and extend the line to the edges of the coordinate. Okay, so just like here, so shade the appropriate area. So since here we have the what they call this one, we have the plot here, no? Okay, so our 3 is x, like this, no? So we have 1, 2, 3. Okay, then here. So the symbol greater than or equal to is used, so we will shade above the y-intercept. So like just like this. Okay. Okay, so step 3, pick 2 point above or below the line and substitute the point into an equality. So you can choose 0, 0. So therefore, 3 times 0 is 0. So 0 plus 2, that's 0 is greater than 2. So this is also false, no? Since the test point makes the inequality false, all points on the side of the lane make the inequality false. So therefore, we were correct to shade above the line. Okay. Example number 3. So the graph the solutions to the following inequality. Okay, so we have there graph the inequality as linear equation. Since the inequality is non-inclusive, use a dashed line. So y is equals to negative 2/3 x minus 1. So to graph the line plot the y-intercept 0, negative 1 because our y-intercept is negative 1. So then use the slope to find the second point. So the slope is negative 2/3. Then count down 2 units to the right, 3 units to the plot of the second. So just connect the 2 points and extend the line to the edge and its coordinate. Okay, like this, no? So shade the appropriate area. Yeah, okay. So since the symbol is less than, it's used to will shade below the intercept. Okay, so this is the technique or the reality, no, in graphing linear inequalities. Okay, so let's continue in the step 3 for example 3. Put a test point above or below the line and set the point to the inequality. So we choose 0, 0, 0 as x, 0 as y. So 0 is less than negative 2/3 x minus 1. Thus, the final answer is 0 less than negative 1. So since the test points makes the inequality false, all points on the side of the line make the inequality false. So therefore, we were correct to shade below the line. Okay. And clarifications, please leave your comment at the comment section. Remember, gratitude is the best attitude. And mega love shout out, advance Merry Christmas to all everyone. I hope you can extend your blessings to this channel because of my advocacy towards our inclusive education. Thank you so much, everyone, to my teams, YTC International, Team Solid Family, and Organic Barcadas. Thank you, guys. Love you all. See you again, especially to all my students. Love you all.